The Lanchester was heavy, machined steel everywhere, slow to manufacture, expensive in machine hours, originally a naval weapon, specified by the Admiralty, intended for shipboard defence, guard duties and boardings. Design lineage was obvious, based closely on MP-28, German export submachine gun, copied with British modifications, conservative attitudes shaped it. Pre-war doctrine distrusted submachine guns. Rifles remained primary infantry arms, automatic fire seen as wasteful. Dunkirk changed calculations abruptly. Losses of small arms accumulated. Threat of invasion seemed immediate. Close quarters firepower gained urgency. The Admiralty moved first, requested a reliable 9mm weapon, demanded robust construction standards, demanded compatibility with bayonets. Lanchester met those expectations. The thick receiver walls provided robustness. Solid wooden stock provided familiarity. Full-length furniture resembled a rifle. For engineers, this mattered. Existing jigs favoured long stocks. Existing skills favoured wood fitting. Existing gauges favoured machined forgings. But every design decision cost. Machined magazine housings consumed time. Complex sights demanded careful milling. Barrel jackets required turning operations. Each receiver started overseer, turned down in multiple passes. Grooves cut for sight bases, dovetails milled for bayonet lug. Every corner required deburring, every screw hole tapping, each threaded portion gauged individually. Tool wear monitored by inspectors. Production forecasts grew unrealistic. Naval orders expanded rapidly. Home defence units requested allocations. War Office remained cautious, however. So the Army saw disadvantages. Weapon mass complicated rapid movement. Long stock hindered confined spaces. Manufacturing cost compared unfavourably. After Dunkirk, pressure intensified. Emergency committees reviewed small arms. Machine tool capacity became central metric. Skilled labour even more critical. Ministry officials requested simplifications. They demanded fewer machining operations. They demanded less reliance on woodworkers. They demanded easier interchangeability standards. Internal proposals accumulated at Enfield. Stirling's designers submitted memoranda. Naval staff submitted operational comments. War Office added qualified interest. One thread gained traction. It proposed a simplified Lanchester. Working name Mark I simplified, often abbreviated as Mark 1S. The logic was incremental. Retain proven blowback system. Retain existing magazines and ammunition. Retain as many gauges as possible, but strip away manufacturing luxury. Strip away non-essential contours. Strip away furniture craftsmanship. Strip away adjustable precision features. Engineers began with the receiver. Original receiver used solid bar, heavily turned on capstan lathes. Machining time per unit substantial. Mark I S considered tubing instead. Standard seamless steel tubing. Bored and honed minimally. Ends faced and chamfered only. Lathe operations drastically reduced. External profiles left cylindrical. No decorative shoulders or steps, only functional cuts permitted. Sighting arrangements reconsidered entirely. Tangent rear sights removed. Protective ears declared unnecessary complexity. Fine elevation adjustments judged expendable. Replacement concept used fixed notch. Simple L-shaped plate welded. Aperture size for battle ranges. Windage adjustment eliminated by design. Front sight also simplified. No banded ramp assembly retained. Post brazed directly to jacket. Crude but acceptable at short distance. Furniture revisions were drastic. Full-length stock targeted first. Walnut supplies already constrained. Skilled stock fitters overcommitted elsewhere. Proposal removed lower fore-end. Retained only a short butt. Midsection exposed bare receiver. Magazine well left completely uncovered. Alternative patterns deleted butt entirely. Substituted steel skeleton framework. Flat bar bent to shape. Butt plate reduced to simple pressing. These changes altered handling characteristics. Weapon felt front heavy. Balance shifted toward magazine housing. Soldiers reported unfamiliar point of aim. Then machine time estimates improved significantly. Furniture steps reduced dramatically. Hand sanding almost eliminated. Checkering omitted without replacement. Engineers examined bayonet fittings. Original Lanchester carried bayonet lug. Naval guards valued this feature. Dockyard planners insisted on compatibility. Mark I's proposals removed lugs. Reasoning focused on production simplification. Forged nose caps no longer required. Bayonet training seen as secondary. Royal Navy objected in memoranda. They emphasized ceremonial and deterrent roles. They noted boarding parties' expectations. Discussions remained unresolved for weeks. Internal memoranda multiplied across departments. Each change required separate approval. Ordnance Board demanded evidence tools, every deletion linked to output gains. Next came fire control simplification. The Lanchester Mark I possessed selector. Single and automatic fire options, selector required extra machining operations, selector slots complicated receiver geometry, additional parts increased fitting effort, polishing of sear surfaces essential, inspection required magnified visual checks. Mark I S deleted the selector, full automatic only mode proposed, strike face geometry kept simple, sear engagement surfaces broadened slightly. This reduced parts count significantly. Simplified trigger guard arrangements, simplified machining of lower assemblies, simplified instructional material for recruits. Safety provisions could not disappear. Drop safety remained mandatory requirement. Engineers retained separate safety catch, engaged bolt in rearmost position, but tolerances tightened on bolt slots. Crude milling could cause binding. Unbinding created partial engagement risk of accidental forward movement. Design Office produced modified drawings, each revision carefully logged numerically. New tolerances added in red, obsolete surfaces darkened or crossed. Shop floor foremen reviewed drawings, they annotated with tool suggestions, proposed specific cutter diameters, proposed new jig arrangements. Gauge designers worked in parallel. Every dimensional change affected gauges. Go and no-go plugs modified. Receiver length gauges redesigned entirely. Inspection officers expressed reservations. They feared creeping tolerance accumulation. Simpler parts could mask variability. Interchangeability targets might degrade quietly. Prototype receivers were fabricated. First units assembled at Enfield, sub-assemblies drawn from standard Lanchester stocks. Only structural changes locally fabricated. Initial firing trials were modest, short bursts conducted indoors. Focus on basic functioning first. Extraction and ejection observed closely. Blowback mechanism remained predictable. Bolt mass unchanged from original. Recoil impulse similar to naval pattern. Cycle rate within expected bands. However, handling degraded noticeably. Lack of fore-end caused discomfort. Barrel jacket heated rapidly under fire. Operators improvised with cloth wraps. Accuracy measurements showed divergence. At 100 yards, grouping worsened. Simplified sights impaired precise alignment. Coarser notch gave broader dispersion. Test teams logged numeric differences. They compared extreme spread values. They compared mean point of impact, differences accepted at close ranges. Tactical doctrines were then considered. Submachine guns classed as short range, expected engagement ranges under 100 yards, beyond that rifles preferred anyway. From this view, accuracy loss is acceptable. Committees stressed manufacturing throughput instead. Quantity over precision became priority. Emergency logic drove many decisions. Attention shifted to manufacturing routes. Existing factories oriented toward machining. Stamping capacity limited but expanding. Welding skills variable across firms. Model 1 S stayed partly conservative, still relied on machined components, still required skilled lathe operators, still required conventional heat treatment ovens. Sten development followed different path. Designers started from pressed components. Receiver tube extremely simple. Magazine housing largely fabricated by welding. Comparative key cost sheets circulated widely. And they listed operations per part. They assigned minutes per machining step. They converted totals to labour hours. Mark I S showed substantial improvements. Versus full Lanchester savings significant. Versus Sten savings looked modest. Sten remained cheaper per unit. Material usage highlighted another issue. Lanchester still consumed more steel. Heavier barrel profile retained intentionally. Furniture still required some wood. Sten minimised material consumption aggressively. Thin tube walls sufficed structurally. Wire stock used minimal metal. No full-length fore-end supplied. Emergency committees framed comparisons starkly. They faced constrained labour pools. They faced constant machine tool competition. They faced limited foreign exchange reserves. One memorandum summarised trade-offs. Lanchester family offered rugged longevity. Sten family offered sheer numbers. Model 1 S sat uncomfortably between. Procurement officers worried about complexity. Multiple variants complicated spares provisioning. Different receivers required different jigs. Training materials multiplied unnecessarily. Logistics branches preferred sharper differentiation. Naval units could retain Lanchester. Land forces could adopt Sten. Intermediate variant risked confusion, yet some engineers favoured Mark 1S. They distrusted the extreme minimalism. They cited Sten's open magazine design. Feeding reliability questioned under field contamination. They noted existing Lanchester familiarity. Workshops already understood its behaviour, existing stock of magazines available, existing repair parts already in flow. Mark 1S required only incremental retraining. Sten demanded entirely new procedures. The new gauges, new fixtures required. New pattern stores had to appear. Trials broadened to safety aspects. Simplified butt assemblies examined carefully. Drop tests conducted from standard heights. Buttstock welds inspected afterward. Some skeleton patterns failed early. Welds exhibited brittle cracking. Heat input during welding inconsistent. Low temperature impact values unsatisfactory. Engineers altered weld procedures repeatedly. They experimented with preheating intervals. They modified electrode specifications slightly. They adjusted joint preparations between tests. Still, failures remained sporadic. Production engineers flagged industrial variability. Small subcontractors might lack consistent control. Inspection burdens would therefore rise considerably. Receiver tubing raised separate questions. Wall thickness variation monitored statistically. Coarse tubing risked bolt misalignment. Fine tolerance tubing reduced savings again. Blowback systems tolerate some variation. But high friction causes stoppages. Low friction risks premature opening. Pressure curves leave the narrow margins. Detailed stress calculations were prepared. Data drawn from prior MP20 studies extrapolated to thinner receiver walls. Fourier methods unnecessary but considered. Explosive overpressure tests were authorized. Barrels intentionally obstructed at points. Receiver deformation measured with gauges. Tube designs failed earlier than bar. However, expected service ammunition milder. Engineers debated necessity of such margins. Historical naval conservatism influenced views, land to service officers more tolerant. Ammunition standardization remained another factor. War demanded enormous 9mm output. Cartridges allocated between weapons types. Gas pressure ranges inevitably broadened under strain. Simplified weapons must tolerate spread. Sten achieved this with mass. Bolt weight chosen conservatively high. Recoil spring rates also generous. Mark 1S retained original bolt. Mass appropriate for the previous envelope. Less safety margin under worse conditions. Engineers recorded this in appendices. Committees compared misfire statistics carefully. Test batches fired side by side. Lanchester variant data tabulated numerically. Sten prototype data recorded identically. Sten exhibited different failure modes. Magazine design remained primary weakness. Feed lips deformed under rough handling. Double column feed path sensitive. Yet faults proved field rectifiable. Soldiers could adjust lips manually. Armourers could rework suspect magazines. New pressings fairly easy to supply. Mark 1 as S faults stemmed from structure. Receiver misalignment harder to correct. Weld cracking required skilled repair. Barrel overheating remained intrinsic characteristic. Advisory groups judged future potential. Sten allowed further simplification iterations. Sheet metal practice could expand gradually. Mass production learning curves seemed favourable. Mark 1S offered fewer avenues. Most simplifications already implemented on paper. Further cost reductions would compromise safety. Accuracy already at acceptable minimum. Administrative considerations then predominated. War Office desired decisive standardization. Training pamphlets easier with single pattern. And spare parts lists drastically simplified. Navy resisted complete Lanchester abandonment. They valued sturdy wooden furniture, preferred bayonets for boarding contingencies. Satisfied with existing production contracts. Compromise gradually crystallized at meetings. Navy would keep standard Lanchester. Army would prioritize Sten adoption. Simplified Lanchester would not proceed. Internal correspondence used neutral phrasing. Terms like uneconomic intermediate pattern, phrases like insufficient differential advantage, language avoided criticism of contributing engineers, design drafts for Mark 1S archived, blueprints stored in technical files, photographs of prototypes marked restricted, serial ranges recorded for accounting purposes, Some prototype units lingered in armories, used for occasional training courses, issued to evaluate handling differences, often retained by experimental establishments. For workshop staff, experience remained valuable. They had practiced tube fabrication methods. They had trialled new welding sequences. They had refined jig location principles. These lessons transferred into later programs. Welding insights benefited Sten evolution. Gauge simplifications influenced other designs. Tolerance policies slowly adjusted to reality. Procurement officers noted another outcome. They saw limits of partial redesign. Legacy constraints hampered radical simplification efforts. True economies required starting afresh. Lanchester embodied pre-war manufacturing habits. Reliance on machining entrenched culturally. Reliance on skilled woodworkers persisted. Reliance on heavy forgings felt natural. Sten deliberately rejected those assumptions. Thin stampings replaced machined housings. Simple bent rods replaced turned levers. Welded assemblies replaced bored blocks. The contrast clarified in minutes. Side-by-side drawings illustrated philosophy shift. One showed layered machining operations. Other showed overlapping stamping operations instead. Mark Is remained philosophically closer. It trimmed edges conservatively. It removed visible refinements cautiously. Core structure stayed essentially unchanged. Capital planning also played role. Machine tools already installed nationwide. Short-term strategy used existing investments. Long-term view encouraged new processes. Officials feared post-war overcapacity issues. They anticipated civilian demand patterns. Stamping capabilities useful for appliances. Are heavy gun lathes less adaptable? These background considerations influenced preferences. They rarely appeared in single memorandum, instead scattered across finance files, scattered across industrial policy notes. Technical assessors nevertheless sensed direction. Resources would flow towards stamped designs, traditional machining reserved for essentials, emergency submachine guns not considered essential. Engineer recollections mention informal comparisons. They described Mark Is as compromised, too crude for naval expectations, too refined for true emergency philosophy. Some workshop comments addressed appearance. Simplified Lanchester still looked respectable, retained recognizable rifle-like profile, did not shock conservative observers. Sten looked markedly different, open magazine well protruded sharply. Their wire stock looked provisional and temporary, finish often left rough and patchy. The phrase ugly gun circulated, not always meant disparagingly, however, sometimes carried quiet approval instead. Utility valued over visual qualities. Official papers avoided such language. They quantified properties whenever possible. Rate of fire measured instrumentally. Grouping and dispersion recorded numerically. Cost per unit emphasized strongly. Machine hours converted to shillings. Materials cost added systematically. Overheads distributed by agreed formulae. Comparative tables underlined decisions rationally. Model 1, S, undercut full Lanchester. Sten undercut both by margin. Margins widened as stamping matured. Training establishments adjusted accordingly. Infantry schools prioritized Sten instruction. Naval schools kept Lanchester courses. Dual documentation accepted as temporary necessity. Ammunition supply remained shared. 9mm production lines expanded steadily. Ballistic performance differences negligible operationally. Doctrine could treat weapons identically. Field reports shaped final attitudes. Early Sten models showed weaknesses. Magazine sensitive to dirt accumulation. Safety handling sometimes criticized by officers, yet users appreciated portability highly. Weight reduction noticed on long marches. Compact form assisted in urban duties. Armoured crews valued storage efficiency. Few field reports mentioned Mark Is, so few prototypes reached operational units. Most feedback came through controlled tests. Documentation therefore remained relatively thin. The design nevertheless marks transition, represents a stepping stone intellectually, demonstrates tension between tradition and necessity, demonstrates limits of incremental modification. From research standpoint, details matter. Specific hole diameters illustrate conservatism. Specific weld lengths show cautious approaches. Specific rejection notes reveal institutional mindset. The emergency context shaped everything. Tooling capability defined design options. Labor skills defined feasible simplifications. Time pressure constrained experimentation curves. Mark S sat inside those boundaries. It attempted to reconcile conflicting pressures. maintain familiar handling and controls, deliver higher output with fewer resources. Ultimately, comparison undermined that compromise. Once Sten existed as benchmark, intermediate patterns appeared less attractive. Resources concentrated on one radical solution, and the Lanchester remained where appropriate. Guarding decks and gangways quietly, serving naval detachments in harbours, providing solid weight against recoil, the Sten flooded other formations, issued to paratroop units in quantity, issued to resistance forces abroad, issued wherever cost dominated selection. Files on Mark I-S stayed dormant, referenced occasionally by later historians, consulted by ordnance scholars and archivists, rarely noticed outside specialist circles, for the Army decision proved pragmatic. They accepted deliberately crude manufacture, they accepted visible weld spatter, they accepted minimal surface finishing. For engineers' lesson remained clear. True simplification demands structural reconsideration, not merely reduction of surface machining, not merely deletion of decorative elements. That the emergency's simplification proposals show this. They show machining still central, they show wood still assumed present, they show incrementalism reaching natural limit. In archival perspective, sequence appears orderly. Minutes lead into subcommittee conclusions. Tables lead into procurement directives. Drawings lead into cancellation notes. On shop floors, process felt different. Workers shifted from hardwood stocks, shifted to tube cutting and welding, shifted to stamping presses and spot welders. The ugly gun became symbol of industrial adaptation under pressure, symbol of changed attitudes to design, symbol of cost overriding appearance considerations. Between these options sat Mark I-S, a design that nearly existed fully, a weapon almost issued widely, yet ultimately bypassed by bolder choice. Tether the Lanchester's simplified variant remained hypothetical. Engineers learned from its exploration. Committees clarified their evaluation frameworks. Factories prepared for more radical demands. In that technical sense it mattered, not as a frontline weapon, but as a conceptual bridge between crafted guns and fabricated tubes. Its absence on battlefields is informative. It indicates decisive selection under constraint. It illustrates preference for extreme economy. It confirms willingness to accept ugliness. The Sten became official answer. Britain's functional emergency submachine gun. Unrefined yet extensively produced. Ugly yet operationally sufficient. Lanchester remained respected naval arm. Carefully machined, carefully stocked. Built to earlier manufacturing philosophy. Maintained long after war's end. A Mark I-S stayed on paper mostly. Proposal stripped for efficiency. A variant deemed not efficient enough. Superseded by something cruder and cheaper. From this sequence emerges continuity. British industry adjusting tool priorities. Ordnance officers adjusting acceptance criteria. Soldiers adjusting expectations of small arms. The simplified Lanchester sits between eras. Halfway from craftsman workshop to factory. Halfway from polished rifle to tube. Halfway from tradition to emergency pragmatism. Its story remains primarily technical. Measured in tolerances and gauges, recorded in minutes and tables, resolved in procurement signatures and cancellations.